this lesson we're going to talk about counting, particularly with tree diagrams. So this first example, it says Coach Erdman is deciding on which jersey his football team is going to wear next season. He has 3 choices for pants: navy, gold, and white, and 3 choices for jerseys: navy, gold, and white. Using a tree diagram, list out all the different uniform choices Coach Erdman could make. So what I mean by this is we're going to have 3 branches for pants. This one is going to represent navy, this one's going to represent gold, and this one's going to represent white. And then if he chooses navy pants, he has 3 choices for the jerseys. He could either choose navy, gold, or white. Same thing with if he chose gold pants. He could choose navy, gold, or white. And if he chose white pants, it could be navy, gold, or white. And so what you do then to count all the different options is you count all the leaves on this tree. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's talk about how we read this here. So like this W that I'm highlighting right now, what that represents is that they chose navy pants and white jerseys. With this other W, that means that they chose gold pants with white jerseys. So each path ends up at a different spot. There are 9 different paths. You might be asked to list the sample space. So the sample space is all the different possible outcomes. So we have navy, navy, navy gold, navy white. That's a weird G. So we took care of all 3 of these. And then we could go to gold, navy, gold, gold, and gold, white. So now we took care of those 3. And then we could say, I don't know, I put a B there. White, navy, white, gold, and white, white. So that would be your sample spaces, listing out all the possibilities. Okay, next one. Mr. Swanson's giving a 2-question multiple choice quiz. Each question has options A, B, C, and D. List out all the possible ways to answer the 2 questions. And give some examples. We're going to make a tree diagram for this. So think about what this is going to look like. Hopefully you have it pictured in your head. The first question, you have 4 choices. You could either answer A, or B, or C, or D. There's 4 choices: A, B, C, or D. If you chose to answer A on the first question, that doesn't limit what your choices are on the second question. You still have options A, B, C, or D. Same thing with the second one: A, B, C, or D. Same thing here. You've got 4 choices: A, B, C, or D, and A, B, C, or D. So you have a total of, if we count the leaves, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So there's 16 different ways that you could answer a 2-question multiple choice quiz. So really, if you just guessed, you'd have a 1 in 16 chance of getting 100% on this quiz. Each of these paths represent a different way of answering. So like this one that I'm circling here, that means you'd answered B, then C. You could list them all out, or this tree diagram kind of shows all the different combinations. Okay, so now Mr. Swanson's going to be making a 3-question true-false quiz, not multiple choice. List out all the possible ways to answer the 3 questions. So I would encourage you to pause it here. This last sentence doesn't make any sense. You can ignore that. I'd encourage you to pause it and see if you can draw this out. See if you can do this without me doing it for you. So first question, you can either answer true or false. And if you chose true, then the next question, you could either answer true or false. And then on the third question, you could answer true or false. So I switched colors so you could see that it's a different question. So there are 8 different possibilities. You could do true, 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 false, true, false, true, true, false, 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 true, false, false. Oh, no, I screwed that up. Whoopsie. It's false, true, true. False, true, false on this one. False, false, true, and false, false, false. 8 different ways that you can answer a 3-question true, false quiz. All right. Next, passwords being created using the numbers 1, 2, 3 and the letters A and B. List out all the passwords that are possible that are 2 letters followed by a number. So, 2 letters, A or B, and then 2 letters, A or B. So maybe I should phrase that differently. The first choice, you have a choice of either A or B, and then on the second letter, you have a choice of A or B. And then on the third part of the password, you have to pick a number, and it's either 1, 2, or 3. So we've got a 1, a 2, or a 3. 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 So if I look at a path here, like that one, that means the password is BA3. Or what if I tried this red one? If I did, that would be AB1. That's a different one. So there's 12 different possible passwords that you could create with this stipulation. A letter, and then a number, and the letters can either be A or B, and the numbers can be 1, 2, or 3. All right, so let's break away from trees and just think about how could we do this without actually making a tree. So you're at Applebee's, you're deciding on what to order for dinner. You're going to choose a drink, an entree, and a dessert. The menu has 2 drinks, 4 entrees, and 3 desserts. How many different ways can you order dinner? So if you think about this, you're going to have 2 drinks, and then 4 branches off of that, and then, because for the entrees, and then 3 branches off of each of those. And you could draw this out, that'd be fine. But if we think about it, the first branches, there's going to be 2 choices. And so there's 2 choices for drink. And then for entree, there were 4 choices. And then for dessert, there are 3 choices. So if we multiply these together, that will give us our total number of outcomes. Because the tree just keeps growing, it multiplies every single step of the way. So 2 times 4 times 3 is 24. There would be 24 different ways you could order this meal at Applebee's. So that's called the fundamental counting principle, is if one event has m outcomes and a second event has n outcomes, then the number of ways they can both occur is m times n. And in this case, it'd be like m times n times p or something like that. Okay, last part here. Timberwolves roster consists of 17 players. How many different ways can we make a starting lineup with these 17 players? So the way this works is you have to choose one of these. You have to choose one of these, one of these, one of these, and one of these. You have to have a point guard, you have to have a shooting guard, you have to have a small forward, a power forward, and a center. So there are 4 point guards to choose from. That means that we're going to start out with 4 branches. And then there's 3 shooting guards, so each of those is going to have 3 branches. And then off of those, there's 3 small forwards, And this is going to get really messy really fast. So I'm going to, like, I can't even fit it all on there. So this is maybe a bad idea. The shortcut is there's 4 choices for point guard, 3 for shooting guard, 3 for small forward, 4 for power forward, and 3 for center. So I multiply those all out. There are 432 possible lineups for the Timberwolves with these given players. All right, so that's it for counting and tree diagrams and fundamental counting principle.